Occasionally when we have two equations, or systems of equations, we need to solve for a variable. To use substitution, we may have to isolate a lone variable. If there are several lone variables, you'll need to pick one to isolate. In example 1, we have two equations, and both of them have two variables. So I'm going to pick the second equation, and I'm going to isolate x, because it would just be a simple addition of 2y to both sides to get x by itself. So now my second equation is x is equal to 2y minus 13. Now that I have isolated x, I can substitute this value in for x in my first equation. I'm going to call this my first equation and this my second equation. Plugging this in for x, into my first equation, I get 6 times 2y minus 13 plus 4y equals negative 14. Distributing 6 through, I get 12y minus 78 plus 4y is equal to negative 14. From here, I'm going to add like terms. This gives me 16y minus 78 is equal to negative 14. Continuing on, I'm going to add 78 to both sides to give me 16y is equal to 64. Dividing both sides by 16, I get y is equal to 4. Now that I have y, or the value for y, I can substitute that into my first equation. This would give me 6x plus 4 times y, which we know is 4 now, equal to negative 14. So 6x plus 16 is equal to negative 14. Subtracting 16 from both sides, we get 6x is equal to negative 30. From here, dividing by 6 on both sides gives us x is equal to negative 5. Notice that now I have both the value for x and the value for y. So I'll write my coordinate point as negative 5, 4. Where this is my value for x, and this is my value for y. In example 2, again we have two equations with two unknowns, where neither x nor y is isolated. So, we'll need to pick one variable to isolate. Again, I see my first equation and my second equation are similar, but this one would be the best to isolate since it's all by itself. So I'm going to add 5x to both sides. When I do that, I have my first equation becomes y is equal to 5x minus 17. So now this same first equation is now rewritten, so I can substitute this into my second equation for y. When I do that, I will now put in the second equation, so I have 7x plus 8 times 5x minus 17 equals 5. Now I can solve for x. 7x plus 40x minus 136 equals 5. Adding like terms, I get 47x minus 136 is equal to 5. Adding 136 to both sides gives me 47x is equal to 141. Dividing by 47 on both sides gives me x is equal to 3. I know x now, and so now I can substitute that back up into my first equation. So I have negative 5x, where I take x and substitute 3 in for it, plus y is equal to negative 17. From here, I can solve for y. Negative 15 plus y is equal to negative 17. Adding 15 to both sides, I get y is equal to negative 2. I now have a value for x and a value for y, and I can rewrite this as a coordinate point, 3, negative 2. And that is my solution to the system of equations.